Welcome to the Polymath World channel, and I'm so excited because today we're talking to another astronaut, and this time from the European Space Agency. I'm delighted to be joined by ESA Astronaut Reserve, Dr. Meganne Christian. Thank you so much, Meganne, for joining me today.
Thanks for having me. It's a pleasure.
Excellent. So, congratulations, first of all, because over 20,000 people applied for that 2022 ESA Astronaut class, and you made it into the astronauts and the astronaut reserves. So, well done.
Yeah, I'm still surprised by it every single day. I have to kind of pinch myself to remind myself that, I got through that selections process, which was pretty intense.
It's incredible. It's the most aggressive, competitive recruiting class ever in human astronaut history. So it's an almighty accomplishment. Has it been sort of a whirlwind 3 years since then?
It has been strange. I mean, it feels both like it happened very recently and like it was a long time ago, but it did really change my life. Even though as a reserve, I'm not guaranteed a mission, so I don't know if and when I will be flying, but I decided that I wanted to get more into the space industry, so I changed careers. I've started training this year, so it's really changed everything. It's been amazing.
Yes, I suppose in a sense you have to be ready for anything because Matthias Maurer was a reserve who then got bumped up, so to speak, and some ESA astronaut reserves have already had flights with the likes of Axiom. So
Yeah, that's right. So from my class of 17, which includes the 5 career astronauts and the 12 reserves, actually so far the people who have flown have been 2 of the reserves. So it's a bit of a strange time for human spaceflight.
yeah, absolutely. We'll get into that later, definitely. I've got a lot to ask you on there, but I'd love to start with your career journey. Did you dream of being an astronaut when you were a child, or is it something that came to you later?
Yeah, I actually didn't really dream of it as a child. So I was fascinated by space when I was first learning about it. When I was in around about year 5 and I started to learn about planets and the stars and black holes. I was fascinated by it, but I didn't actually think of it as a possible career. Partly that's because I grew up in Australia. I was born in the UK, but grew up in Australia, and there was no space agency at the time. And so I just didn't really think of space or being an astronaut as a possible career path. And it didn't come to me until much, much later, when I spent a year in Antarctica, which I'm sure we'll talk about as well, but doing the kinds of things that astronauts do on the International Space Station, but in a different kind of extreme environment. And so it seemed like the next logical step from there.
Yeah, were you always very much a science and maths nerd, though?
I was one of those kids that changed their mind every single day about what they wanted to do with their life. I for a while I wanted to be an architect or an actress or a diplomat. But I did know that I loved sciences and I particularly loved maths. At the same time as really enjoying languages as well. So I kind of narrowed it down to chemistry. I did chemistry in my last couple of years of school. And then I found this Bachelor of Engineering degree in industrial chemistry. And before that, I really hadn't considered doing engineering, even though I really did love maths. Um, but this particular degree was interesting because it allowed me, with the scholarship I had, to do industrial training placements and learn a bit about what it was like to work in industry during that degree. And so I did that. I ended up in engineering, which was just perfect for me.
Amazing. And from there you specialize in material science. And I always find that interesting because students can't pick material science as an A level. Yeah, and
That's true.
it's just sort of something that comes incidentally, and people have to choose to take that step into it. So what was it that drew you into material science, and what was your research?
I kind of fell into it in a way. Because of that degree that I did, it had a quite a mix of chemistry and physics. And that's essentially what material science is. It's a real mix of chemistry and physics. And the work I was doing for my undergraduate thesis was on hydrogen storage, so storing a large amount of hydrogen in a small amount of space for fuel cell vehicles, so alternative energy applications. And that got me really interested. I was using nanomaterials to do this. And so I decided to continue and do something similar. I was kind of extending the research that I did there in my undergraduate thesis into my PhD. again, working on nanomaterials for hydrogen storage. And so, yeah, it was basically, I kind of fell into it. I call myself a materials scientist because I work with materials, but I didn't do a degree in material science, although a lot of what I did in my industrial chemistry degree overlapped with my colleagues in material science.
Fantastic. Well, I want to ask you about graphene here because graphene is the kind of the super material everyone is swearing by and has been waiting for. And it has featured in your research bit. So tell us a bit about graphene, why it's important, its applications, and what your research has been.
Well, after my PhD, again, I wasn't exactly sure what I wanted to do, but I was pretty keen to get some international experience. And so initially, I found a postdoc in France, and I had studied French at school, keeping on going with hydrogen storage. But in the end, they didn't get the funding for that postdoc position. So I was looking again. And through a professor that I had met at a conference during my PhD, as happens quite often, I found out about this other position in Bologna in Italy, place that I had never been before. I didn't speak Italian, but it was on graphene, and this was in 2014. So it was 4 years after the Nobel Prize had been won for the first sort of synthesis of graphene. And I was fascinated by it. It was really, really, really interesting. The more I read about it, the more I was interested in this incredible material, which has really superlative properties. You know, it's a brilliant conductor both electronically and thermally. It's extremely thin. It's a one atomic layer of carbon atoms, which means that it's also flexible and transparent. And so it has a whole range of different applications, particularly in electronics. Flexible, wearable, stretchable potentially if you combine it with polymers, touch screens for new devices and that kind of thing. But what I ended up doing with it, and I was really on the synthesis side, so making this graphene and optimizing the processes for making graphene and characterizing it, but using it for alternative energies, so using it in batteries and in supercapacitors. And then this is where my first sort of space-related topic came in, was when I was using the graphene that I was making for cooling devices in satellites. So using the graphene as a coating to enhance the thermal conductivity and also to enhance the properties of this wicking material that basically needs to pull the fluid through the loop heat pipe. And so that is when I got the chance to go on my first parabolic flight. And so that was the first thing that I really had to do with space. But at the time, I was not thinking about changing career into the space sector.
So when did space enter into the picture?
Well, so after that parabolic flight, I was certainly tickled by the idea, but again, didn't really think that it was a possible career for me, especially since there hadn't been an astronaut class for many, many years, and I didn't really know much about the European Space Agency at all. Of course, I knew about NASA. Everybody knows about NASA, but ESA is a lot less well known. And so it wasn't really on the horizon until I went and spent a year at Concordia Station in Antarctica. And at Concordia Station, the European Space Agency sends a research doctor to do tests on those of us who spend the winter there because it's the best analog we have for what it would be like to do a mission to Mars. In fact, it's called White Mars as well.
Mhm.
So this research doctor goes there and they're doing tests on us as if we were going on a Mars mission to see what happens to our body, what happens psychologically during that time. And so I was learning something about the European Space Agency. I was also learning a lot about myself because before I went there, I had not had anything to do with atmospheric physics and meteorology, which were the subjects that I was, well, the observatories that I was looking after at Concordia. And so I was concerned that I wasn't going to be able to do the job that I needed to do all the troubleshooting with electronics and programming and so on, which I hadn't had a lot of exposure to before. But then I got there and I loved it. I loved that really steep learning curve that I had in the first couple of weeks of handover with the previous winter over crew. And so I was learning that I could do these things. And I was also being inspired by this incredible extreme environment. So these three factors together, learning more about ESA, learning about myself, and the fact that I could do these things, and also just this really enjoying the extreme environment kind of made me think that the next step was to try doing something similar in space. I mean, illogical, right? But it's clearly the next step.
Concordia is such a, you're right, it is an extraordinary analog. But you're very far inland from Antarctica. You're completely cut off during the winter. It's a long stint with a team that you're going to be very close to, but you could also get sick of each other's presence, I suppose. It seems to stretch people in ways that are difficult to prepare for.
Yeah,
Um,
I mean, I think physically you know what to expect because you know that the temperature is going to be extremely low. We got to a wind chill of minus 104 degrees Celsius, for example, and I was
wow.
working outside every day, so I got to experience that. And there are 100 days of darkness where the sun doesn't rise. There's really low humidity, and you're also at high altitude, so just climbing a flight of stairs is tiring. It's tiring to be there, but it's really the psychological aspects and trying to keep up the group morale that's the more difficult part, I would say, the more challenging part.
yes, I've spoken to Dr. Beth Healy quite a few times, who did a Concordia trip as a doctor. And she talked about the fact you don't see any children or old people for a year, and you're only seeing white everywhere for a long time. So there's a visual, so no trees, nothing. There's so much visually that is a stretch that is difficult to prepare your mind for. What was the best thing about Concordia, and what did you find most challenging?
I think the most challenging was probably maintaining good relationships with the crew, because I found that especially during the long period of darkness, people would tend to be more irritable, myself included, because you weren't sleeping as well. And it plays kind of havoc with your emotions and how you're feeling. I think you really feel any emotion more strongly than you usually would. If you feel a little bit lonely, you'd feel quite down. If you feel a bit happy, you feel quite over the moon. So taking that into account in your personal relationships and making sure that you're really getting along with the rest of the crew was probably the most challenging part. But also, I mean, ultimately, that's what you take away from it as well, having this little family that you've made, spent a year with while you're down there. But I think some of my best memories were of just enjoying that environment. So one of the tasks that I had was to walk out to this instrument tower that was about 1 kilometer away from the base. And then had to dig up the snow to get into the shelter underneath, put on a harness, and then climb up this tower and clean all the meteorological instruments that were on it, come back down and do it all in reverse. And this also during the 100 days of darkness, this was something we had to do every week. And also uh, as I said, low oxygen levels from the high altitude. So it was pretty tough, but it was also just the best part of the week because my colleague and I that had this task, as we were walking out there or as we were walking back, we would take our headlamps off and just let our eyes adjust to the darkness and look up at the polar night, which was absolutely incredible. You feel like you are inside this wrapped in this blanket of stars. And if it's a moonless day, you can actually look down at the snow and see your shadow in the light of the Milky Way. That's how bright the stars
Gosh,
are.
wow. Well, I bet your view of the Milky Way must have just been spectacular. The people I know who've gone say they miss it. That's something that they can't get anywhere else.
Yeah, it is. I mean, I've had something similar probably in the outback of Australia, and it's a little bit better there only in terms of actually being able to uh, spend a lot of time out there. Whereas at Concordia, you can only spend, maybe half an hour outside if you're really pushing it, and you really need to spend time to let your eyes adjust to the darkness. Although I have to say, there's clearly not a lot of light pollution down there, but it's really difficult to find locations where you can get such an amazing view. But I definitely miss Antarctica, and in fact, I did go back again not for a whole
Oh,
year, but just for a summer season.
Wow. That well, you're very blessed. That's pretty special. Um, so you apply to be an ESA astronaut, and you find out you're going to be part of the reserve. Tell us about your training and what you've enjoyed about it and what you found challenging.
So I've just started. Initially, the reserves, we didn't know if we were going to have training. It wasn't initially on the cards. We were just kind of waiting until we were called up for a particular mission, and then we'd go and train for that mission. But the European Space Agency and its member states decided that it would be really helpful to train the reserves so that we have we're more prepared if we do get that call, especially since there have now been two members of the reserve that have had that call. So, so yeah, we're doing elements of the basic training. I've done my first 2 months. My next 2 months are coming up very soon. And that included things like human behavior and performance training. So skills that everybody needs in every aspect of life. This training is super helpful, I think, probably for everybody. So things like teamwork and leadership, followership, also cross-cultural awareness, situational awareness, stress management, but applied to a situation on the International Space Station in particular. And then, since we all come from really different backgrounds, some of us are scientists, some are engineers, some are doctors, and some are test pilots, it's all about kind of bringing us all to a certain level across a range of different disciplines. So, we all also do scientific subjects, and the first one that we did was biology. We've got human physiology coming up soon. We also did training in the neutral buoyancy facility. So yes, here on Earth, you can train for being in weightless conditions by doing things like parabolic flights, but those you only get 22 seconds at a time of zero G. So to train for a spacewalk or an extravehicular activity, the best way to do that, because a spacewalk is going to be 6 to 8 hours, is underwater, using the buoyancy of the water to kind of simulate that weightlessness. So we did our first introduction to that during the first lot of training, which was really exciting.
Was that in Houston?
This was actually at the Neutral Buoyancy Facility in Cologne. But
Right.
now that I've certified there, I am allowed to dive as a guest diver also in Houston, which is really
Oh,
exciting. I'm
excellent.
hoping to
Y-
have that opportunity one day.
Yes, certainly. Are you having to do language training as well?
Not yet. It's not part of the curriculum, although I love languages, and so I do a bit of language on the side of I've studied French and Japanese at school. I'm fluent in Italian after spending 9 years in Italy. Learning a bit of German and Russian and going
Wow.
back to my Japanese as well.
Gosh. Well, you certainly seem to tick so many boxes of what would be required of an astronaut. You have the science, the languages, the maths. You have the polar experience, the extreme environment experience. You've been flying, and also you seem to have all these interests like having a black belt in martial arts and lots of outdoor activities and sports. You seem like a I mean, we love polymaths on this show, so you seem to very broadly talented. Um, do you have any expectations about flying, or what are you hoping for?
Yeah, I mean, I have to not have any expectations because there are no guarantees. It might not happen for me. But I think with the rise of short duration commercial space flights, for example, there is an increasing possibility of it happening. And so I'm hopeful. I I like I said, no guarantees, but I think it will probably happen one day. So yeah, I'm trying to enjoy the training and just put that off and see what happens in the future.
What will you most be looking forward to?
So there are a few different things. I just can't wait if I get the opportunity to look back at Earth from space, whether that be most likely from the cupola of the International Space Station or perhaps from one of the next generation of space stations. I mean, if in my wildest dreams I ever got to set foot on the moon, looking back at the Earth from the moon like we look at the moon from Earth would be absolutely incredible. But also, the more I learn about the science experiments that go on the International Space Station, the more I want to get involved. And I would be really curious to try synthesizing graphene in zero G. I think it has the potential to make a much more perfect crystal than anything that we can make here on Earth.
Yeah, material science research for space is extraordinary. I mean, going back to the days of the space station Mir, the Russians were doing some really innovative work in material science there, and obviously the applications for space are immense. I was speaking to NASA astronaut Ricky Arnold yesterday, and he says that there's about 300 experiments a day are going on the ISS, and I've been very fortunate to have an experiment flown there myself. It's incredibly groundbreaking, a real world-class laboratory. But it does seem like science in space, even after the ISS, is going to be a big part of what happens with commercial space stations. So, are you looking to sort of, in your ambitions, be the next sort of great British space scientist?
That would be incredible. Of course, I'm not the only one from the UK. We also have a career astronaut, Rosemary Coogan, and we have the world's first astronaut with a disability, John McFall. I mean, if we get the opportunity to go to space, all of us, that would be incredible. But I mean, the reason that we go is to do that science, and yeah, absolutely. I mean, it would be an incredible opportunity to do that, and just like when I was in Antarctica, when I was the custodian of other people's experiments, I was being the hands of people who had put their life's work into designing these experiments but couldn't be there themselves. That's what astronauts do on the ISS as well. So that's a huge responsibility, but also it's an amazing opportunity.
Now, the million-dollar question here to all astronauts that I love to know is, so you've done Concordia, White Mars. I'm on the board of the Mars Society here in the UK, so we like to advocate for that. Would you go to Mars,
I
even just
I
for a flyby?
I would go to Mars. I think that, yeah, I think it's kind of the next frontier, right? I think we uh, we will inevitably get there. And yes, I myself would go as long as it was planned to be a return mission. I'm not keen on the idea of going there and colonizing and staying. I love the Earth, and I want to come back. I recognize that, there's the possibility that I wouldn't come back in terms of things going wrong with the mission, but as long as it was planned to be a return to Earth, then I would absolutely go.
Amazing. I'm delighted to hear that. Obviously, with Mars, with its orbits, you kind of have the choice of going for 30 days or 2.5 years.
Mhm.
Would you be opposed to the 2.5 years if it was obviously so well set up that you can come back?
Yeah, that would be something to consider very carefully, obviously, with family, and what that would mean. Um, I wouldn't say no to it, but it couldn't just be my decision.
Yes, yes, of course. That's always the thing here. You have another role with the UK Space Agency. Could you tell us about that and what that involves?
Yeah, so when I was selected as a member of the reserve, that just meant basically continuing with my day job, and being called upon by the European Space Agency, to do my yearly medical checkups, also to do some kind of outreach activities, and now to do training as well. But I decided that I wanted to get more into the space sector, so I got a job at the UK Space Agency, and I'm in the exploration team. And initially, that was all about our planning for post-ISS. So the International Space Station is going to be decommissioned in around about 2030. And after that, we've spoken a little bit about it before, there are going to be commercial space stations. And so I'm trying to make sure that the kind of science and research that we're doing now on the ISS continues into the future with these commercial space stations. And now since then, I've kind of expanded the role. I'm looking into some other things as well. So I'm working on in-orbit manufacturing, particularly interested in how, the market for in-orbit manufacturing of pharmaceuticals, which has the potential to really revolutionize, the way we have medicines here on Earth, and also looking into space nuclear. So whether that be, radioisotope heating units that we have on rovers on Mars, or whether that be a microreactor on the surface of the moon to supply our energy during the long nights, the 14-day nights that there are on the moon. or whether that be nuclear propulsion going much further afield.
Very exciting. That's terrific. Um, what are your hopes for the future of space? It's an interesting time. You mentioned the decommissioning of the ISS. I really can't imagine life without it at this point. But we are moving into a future which, on the one hand, seems very exciting and on the other seems very uncertain. What are you really excited about for the future of spaceflight?
Yeah, I think we are in a moment of uncertainty, but also a moment of opportunity and promise. And so I'm really excited to see the next generation of space stations, whether that be one, two, three, or more. Um, it's difficult. It's challenging for these companies that have to come up with a business model for how they're going to work. But there's an opportunity there too, because the ISS is not really set up to be something that makes profit. So these new space stations do mean that there's an opportunity to do things like making products that can be sold on Earth, or filming, or space tourism, and whatever you think about space tourism. I think as long as it's done in a regulated and safe sort of way, the more people that have the opportunity to see the Earth from space and have the overview effect, the better. So I
Absolutely.
think I think that's really exciting. I think opening up access to space and going further, going back to the moon, staying on the moon, and eventually getting to Mars. I think it's just really exciting. And so my hope is that we continue to explore. We're not held back by politics, by squabbles between countries, and that we do it in a collaborative way. We do it in a regulated way, in a as sustainable a way as possible.
Absolutely. That's very well said. You mentioned outreach a moment ago. How much does science communication play into your job?
It's a really important part because if you have astronaut in your title, or even if you have do something to do with space, kids tend to be quite excited about it. So that gives you a kind of platform to be able to talk about science, to talk about the important research that's going on, and hopefully inspire them into doing science or engineering or maths in the future, or just trying to set them on a path to doing something that they love that doesn't have to be STEM. And I try to get the message across that they don't have to be worried about the subjects that they're selecting now at school. They don't have to feel trapped by that, because your career path is not necessarily linear, and you have to, always be on the lookout for opportunities. And if it's the right time, and if you're brave enough, you can take them. And that's how I ended up going to Antarctica, and how I ended up applying to be an astronaut.
Yeah, it's so powerful. I don't think anything inspires a young person like an astronaut does. Yeah, I was 7 years old when Helen Sharman became the first British astronaut, and I was 8 when Michael Foale flew, and he's been my hero all my life. I think lives have changed, really. It's such a big, hopeful picture that inspires young people. Um, and speaking of which, what advice would you give young people who want to follow in your footsteps? All the little, all the Meganne Christian juniors out there. What would you say to them who want to get into this field?
Well, I think the most important thing is, first of all, to be doing something that you love. And we come from really different backgrounds, as I was mentioning before. So that doesn't have to necessarily be something within the aerospace sector. It can be many, many different things. As long as you're kind of developing these transferable skills that you can get you into it, then if you're really enjoying it, and that means that you can be at the top of your game, and that means that you have more opportunity to be able to get into it. But also, if you're doing something that you really enjoy, yes, unfortunately, becoming an astronaut is still it's difficult. There are only a few positions available. So if you're doing something that you really love, then getting that position would be a bonus, the cherry on top, but it's not a requirement. So I think it's important not to completely dedicate your life to that singular goal, because luck comes into it as well. But do the things that can kind of help you along the way, as long as you enjoy them. So that's where being a polymath comes in, really. That, being a well-rounded person. I think all of the astronauts have a lot of different interests, and pursue a lot of different things, and we enjoy a lot of different things, and that is what has helped us to then be selected.
That's great advice. If people want to find out more about you or follow your progress, where should they go?
Yeah, I'm on basically every social media platform as Astro Meganne. Sometimes Astro Meganne or sometimes Astro underscore Meganne, or on LinkedIn at Meganne Christian.
Brilliant. Thank you so much. And the best of luck to you. It's been a pleasure talking to you. I'm really looking forward to seeing yourself and Rosemary and John all fly.
Thank you. Thanks very much.
Thank you so much for watching. Don't forget to like and subscribe. Stay tuned for more amazing conversations with incredible researchers who are changing the world we live in and driving humanity forward. Feel free to check out my Instagram at polymath_Sam or go to my website at www.sam-mckee.co.uk.